Alright, this video is going to be on how to find the integral of inverse trig functions. So we have, again, three rules. We have 1 over the square root of a squared minus u squared, where a is a constant. And that equals sine inverse of u over a plus c. We have the integral of u times the square root of u squared minus a squared, which is 1 over a times secant inverse of u over a plus c. And we have 1 over a squared plus u squared, which is 1 over a times tan inverse of u over a plus c. Alright, so our first example, we're going to evaluate this definite integral from 0 to 1/4, and we've got 1 minus 4x squared dx. And if you look at all three of these, what they have in common is it's something squared minus something squared, or in this case plus. So we have to rewrite this so we can see what our two squared terms are. So that first one, that'd be 1 squared, which you can write as 1 squared or you can write as 1, doesn't matter to me. And then the second one, if I think about what must have been squared that would give me 4x squared, that must have been a 2x. And so that helps me set up my u substitution. So if I compare this, I can see that this problem is similar to the first one. And so my u is going to be 2x. And that means my du is 2 dx, which I do not see in the problem. So now I'm going to be taking 1/2 times the integral of 1 over square root of 1 squared minus u squared du. And for me to be able to put the numbers in that I'm going to evaluate this as, I have to say u equals 2 times 1/4. And 2 times 1/4 is 1/2. And I'm going to say u equals 2 times 0, which is 0. And so now I can go ahead and do this integration. So I know I've got the 1/2 in the front. And then this is this one, so that is sine of u over 1. And we won't write plus c because we're evaluating this one for 1/2 and 0. So now I can go ahead and do the math. I have 1/2 times sine inverse of 1/2 minus 1/2 times sine inverse of 0. And of course I have my unit circle handy. So for trig inverse functions, if you guys remember, for sine we were only able to look in quadrant 1 and 4, and I'm sure you don't remember that. But sine is the y-coordinate, so I'm looking in quadrant 1 and 4 where the y-coordinate is 1/2, and that's right here. So sine inverse of 1/2 would be pi sixths. So I have 1/2 times pi sixths minus 1/2 times sine inverse of 0. I'm looking in quadrants 1 and 4 where the y-coordinate is 0, and that has a radian measure of 0. So that's nothing. 1/2 times pi 6 would be pi 12ths. And again, just like we were discussing before, if you were to plug this into your calculator to evaluate it and then plug this decimal in, your answers should be the same. And so that's a good way for you to check your work as you do these problems. Alright, the next one, we've got x over x to the 4th plus 9 dx. And again, I'm going to rewrite it so it matches the form of one of these. So if I look, it's not one of the ones with the square root, so it's the most similar to this one. And I'm going to rewrite it so I can see what the squared terms are. So I've got 3 squared plus x squared being squared. And I went ahead and switched the order just to make it match that rule up there. So that means our a is 3 and our u is x squared. So u equals x squared. That means that du is 2x dx. And I can see the x, but I can't see the 2. So that means that the integral that I'm trying to find is 1/2. And that would give me 1 over 3 squared plus u squared du. And I know that when I do that, that gives me 1 over a. So that's going to give me 1 over 3, or actually I had the 1/2 in the front, so I'll go ahead and put that first. So I have the 1/2 in front, and then based on my rule, that gives me 1 over a times tan inverse of u over a plus c. And if I go ahead and fix this, I can say that these two things multiplied together is 1/6 tan inverse. And then my u was x squared, so I have x squared divided by a, which is 3, plus c. All right. And then we've got just one last example. So our third example is going to be 5 over 3x times the square root of 9x squared minus 1. And again, I'm going to rewrite this so I can see what my terms are, because these all have squared terms. So I've got 3x in the front, and then the thing that was squared to get 9x squared would have been 3x minus 1 squared. And so in this problem, I can see that it matches this one right here. So that tells me that my u should be 3x, and my du is 3 dx, and I do not see a 3 in the problem, so I need to divide by 3. And this 5, it should be a 1 normally, so I'm going to go ahead and take the 5 out, and I'm taking the 1/3 out, and so that gives you 5/3 in the front of your integral. And then I've got 1 over u times the square root of u squared minus 1 squared. Du. And then if we compare that to the little rule we have, we're going to have 5/3 times 1 over a, which in this case would be 1 over 1, secant inverse of u over a, and we're going to say plus c since we're not evaluating this for specific numbers. And so that gives me 5/3 secant inverse of 3x over 1, which is just 3x, plus c.